Okay, in this video we will learn how to store and access elements within tables in MATLAB. Okay, so tables, I'm going to call them arrays and matrices. For right now, arrays and matrices you can think of as kind of the same thing. This is not just a specialty application. We will need matrices the rest of the term because matrices are a convenient way of processing lots of data at one time. Instead of taking one number and processing that one number, and then taking another number and processing that number, we can take the matrix or the table as a whole, process the table as a whole. Okay? And this is really the strength of MATLAB. In fact, MATLAB is short for Matrix Laboratory. So first of all, I'm gonna draw a table over here. Let's say I've got a table where the first row is 1, 2, 3, and the second row is 2, 3, 4. And then the next two rows are just the sum of the previous two rows. So to get the third row, I will add rows 1 and 2. So let's say I've got this, 3, then 3 and 2 is 5, and 4 and 3 is 7. And then let's say the last row, the fourth row, is the sum of the previous two rows. So the 3 and the 2 make 5, and the 5 and the 3 make 8, and the 7 and the 4 make 11. Okay, so this is my table, and I'm going to use this example for the entire video. And I want to get this table into MATLAB. Okay. First of all, tables can have any number of rows and any number of columns. Okay, it does not have to be a 4 by, we would call this a 4 by 3 matrix or table. Okay. Because the 4 is the number of rows comes first, and then 3 is the number of columns comes second. It doesn't have to be 4 by 3. Okay, it can be less rows, less columns, more columns. This is also referred to as the dimension. This is the dimension of the matrix. A vector is a special kind of matrix whose either rows or column, number of rows or number of columns, is 1. So if I have a 1 by something matrix, that's a vector. If I have a something by 1 matrix, that's also a vector. And a scalar is a special vector, and it's a vector whose dimensions are 1 by 1. So a scalar is a 1 by 1. In the previous lesson, we looked at only scalars. That is, just if it's got one row and one column, then it can only hold one number. Okay, one number, so that's a scalar. Okay, so I want to get this table into MATLAB. So the first thing I want to do is decide on a variable name. Okay, so let's just call it capital M. Capital M for matrix. Okay. And as is usually the case in programming, there are a lot of ways that I can go about doing this and get the same result. I will give you the most general, kind of most straightforward method first, and then we'll look at other methods of getting this table into MATLAB. Okay, so the first thing I'm going to do, if I want to define a matrix in MATLAB, I'm going to need a square bracket. Okay, so I'm going to put an open square bracket there, and that's MATLAB syntax telling it to expect a matrix. So what I'm going to do, I'm going to start here at this first element, the top left of the table. So I'm going to put a 1 there. And then I'm going to proceed to the right. Okay? And so I need to tell MATLAB that, hey, I'm moving columns now. I'm moving to the next column. So I can do that with either a comma or a space, or both. And so I will usually use both, comma, space. So now I'm in the next column, so I'll put a 2. And then I need a comma, space, 3. Now I've reached the end of that row, and I need to tell MATLAB that I intend on moving to the next row. So I will put a semicolon. Okay? I need a semicolon there to tell MATLAB that I'm going to the next row. So here again, here's another use of the semicolon. We've seen many uses of the semicolon. Here's another one. So now I've started the next row, so I will put 2, then comma, space, 3, comma, space, 4. So I've reached the end of the second row, so I will put a semicolon to indicate I'm changing rows. 3, comma, space, 5, comma, space, 7, and I've reached the end of the third row, so I will put a semicolon there. 5, comma, space, 8, comma, space, 11. Again, you don't need the commas and the spaces. One will do. Now, after I've reached the end of the table, okay, you see I put another square bracket there to close the matrix. Okay, and I'll put a semicolon at the end because I don't necessarily want it to echo back to me. And I'll hit enter. Okay, and so notice now M is in the workspace. Okay, and if I look at the workspace, you see it's got it says its value, it's a 4x3 double. Okay, 4x3 tells us the dimension of the matrix. A double means it's a double precision float. We don't need to know what that is at this moment. And if we keep scrolling, you see it tells us the minimum of the matrix, it's 1. And it tells us the maximum in the matrix, and it's 11. Okay. If we wanted to see the matrix, we could hit M, enter. And there it is. It's echoed back to us now. Now suppose I want to access elements of the matrix. For example, maybe I want the 3 that's located in row 2, column 2. What I can do is say, okay, capital M, that's our matrix name, and I'm going to access elements using parentheses. Okay, so I'm going to use an open parenthesis there, and I'm going to put the row first. Okay, so this is consistent with this idea here, the 4x3 matrix, where the row comes first and then the column. So I'm going to say, hey, I want the element that's in the second row and second column. Okay, what is that? So I'm just going to close the parentheses there, hit enter. And it says, oh yeah, that answer is 3. Meaning there's a 3 that's stored in location 2, 2, second row, second column. Maybe I want to change that number. Okay? Maybe I want to change it to a 0. Okay, so I'll say, I'll access that element again, like that. And now I'm going to say equals 0. Okay, now if I look at the matrix again, see I've got a 0 right there. Let me make it a 3 again. M of 2, comma 2 equals 3. That will make it a 3 again. If I leave off the semicolon, it'll show me the entire matrix. This works for variables too, of course. So I can say, hey, let's call a variable row 2. And let's call a variable col equals 2. All right? And instead of saying 2, 2 directly, let me say row, comma, col equals 0. But see, row is currently 2, and col is currently 2. And so this is equivalent, this statement here is equivalent to this statement here. Okay, so I'll leave off the semicolon, so you'll see, again, that's zeroed out there. And if I want to make it a 3 again, I can type m of row, comma, col equals 3. And there it is again. Okay. That's one way of accessing the elements in the matrix. Saying row first, comma, col. Okay, let me clear the command window, CLC. And remember, M is still in the workspace. So I can hit M, there it is. That way of accessing the element, saying row and then column, that's called subscript notation. And it requires 2 numbers. It's like a grid. So it requires the row and it requires the column. I can also access elements using 1 number. MatLab stores matrices, tables, in column major order. So what that means is it stores it in memory as the first column stacked on top of the second column, stacked on top of the third column. So let me draw that over here. So it's like MATLAB stores it like this: 1, 2, 3, 5. That's the first column, and then 2, 3, 5, 8. That's the second column. 3, 4, 7, 11. That's the third column. That's how it's actually stored in memory, column major order, with the columns stacked on top of each other. So if I wanted to access the 1 that is at the top left of that table using the previous method of subscript notation, okay, that's 1, 1. That's row 1, column 1. In fact, that gives us a 1. I can also just say, hey, how about the first element? Okay. So you see I'm using an open parenthesis and I'm telling it just the first element, and then a closed parenthesis there. Okay. It tells me, yeah, that's a 1. The first element in the table is a 1. Okay. This is called linear subscript notation. Or, sorry, linear index notation. Linear index notation. So now, if I ask it for the second element, and that's a 2. Okay. Because over here in my picture, okay, the second element in the stack of columns is a 2. Okay. In other words, this element right here is a 2. Okay. And if I ask for the third element, it's a 3. Because this element here is a 3. Okay. Now if I ask for the fourth element, what's it going to give me? Yeah, 5. Okay, because this element is a 5. The sixth element is a 3. Okay, because now it moves to this guy here. I skipped an element. I went from 4 to 6. So now we're looking at this guy right here. Okay, row 2, column 2. And then the stack, the sixth element is 1, 2, 3, 4, 5, 6, a 3. Okay? So if I want to change that element to, say, a 0, I can also say, using linear index notation, m of 6 equals 0. And I'll leave off the semicolon so it's echoed back to me. And there it is. Okay. So I have 2 options when I want to access elements in a table or a matrix. I can use subscript notation, where I give it 2 numbers, the row and the column. Or I can use linear index notation, in which I just give it 1 number, the linear index. Okay. Good. Okay. At this point, I want to show you some built-in functions that can help us process our tables and our matrices, and a built-in keyword, end. Okay. So end is a keyword in MATLAB, and if you type end, you'll see it turns blue. Okay. When it turns blue, that means it's a keyword, and that means it's reserved in MATLAB. So I don't want to use end as any variables because it's already reserved into MATLAB, and it means a very particular thing in MATLAB. Okay? So with m stored into memory, I can ask it, hey, what's the last element of the table? M of end. It says, oh yeah, that's 11, because the last element in this stack is 11. Okay? That is this guy right here. And I can also say, well, what about the second row last element? Right? So what is that going to give us? Yeah, 4. Right? So there it is. The second row, last element. That's a 4. And I can continue, and I can do other things like this. I can say, I can treat end as a variable, actually. End minus 1. Okay, so this is saying the second row, end minus 1 element. So that would be this guy again, 0. There it is. Okay, end is a keyword. It's reserved for MATLAB. MATLAB knows what you mean when you say end. You don't have to define it. In fact, you shouldn't define end anywhere because it's reserved. Okay. Now I want to take a look at size. Size is a built-in function. Okay, it's built into MATLAB. It knows what you mean already when you type size. So I'm going to type size and use an open parenthesis, and I'm going to put capital M there and close the parenthesis. So what I'm asking is, hey MATLAB, tell me what the size of M is. So when I hit enter, it returns 4, 3, meaning it has 4 rows and 3 columns, okay, just like this over here. So we can get the size of M that way. I can also ask, what is the length of, let's say, I'm going to back up. I don't want to use the length just yet. We'll come back to length. Okay, now I'm going to clear the command window, CLC. I'm going to clear the workspace. Okay, so now our matrix M is gone. If I want to see M, it says undefined function or variable M. Now I'm going to show you a couple different ways of inputting the same matrix. Okay. Now, what we did before, just to remind you, is we used the square bracket, and then we entered all those numbers by hand. What a painstaking process that could be if M were very large. Okay, but if you see a pattern in the matrix, you can exploit that pattern. Okay, and the first way I want to show you is using the colon operator. So let me define a new variable, call it row 1 equals. And what I'm going to do is I'm going to say 1 colon 3. And what this tells MATLAB is to start at 1 and go to 3 in increment or steps of 1. Okay, so if I hit enter, you see row 1 now is a vector. Okay, it's a 1 by 3 matrix. It's got 1 row, 3 columns, and it goes 1, 2, 3. Okay, similarly, I can say row 2 equals 2 to 4. I'll leave off the semicolon so you can see it. Okay, it starts at 2, it increments by 1, and it goes to 4. And it's also a 1 by 3 vector. Okay, so I've got row 1, I've got row 2. So now I can start to build my matrix, and I can say M equals, okay, and then I have my square brackets, okay, and I'm going to just type row 1. Okay, so that's the entire first row, 1, 2, 3. And now I need a new row. So remember, the semicolon is for a new row. And then I'm going to put in row 2. And I'm not finished yet, but I'll close that square bracket and just take a look at it by hitting enter. Take a look at it. So right now, you see I've got the first 2 rows. See that? Of M. So this showed you how we can use the colon operator. The colon is very important to MATLAB syntax. Colon operator tells us, or tells MATLAB, to exploit this pattern. 1, 2, 3, or 2, 3, 4. Start at one number, finish at the other number in steps of 1. And it does not have to be in steps of 1. For example, if I had a vector, vec, if I wanted maybe the odd numbers up to 11, 1, 3, 5, okay, so forth, I could say start at 1, colon, increment by 2's, colon, to 11. Okay, so you see I'm using 2 colons here, and the number in between the 2 colons is actually the step. There it is. 1, 3, 5, 7, 9, 11. Okay, that second colon and the third number, the number in between the 2 colons, okay, is optional. And if you leave those out, MATLAB assumes that you want to step by 1s. Okay, which was what we did in this case. Okay, if I want the even numbers from 0 to 10, I can say vec equals 0 to 2 to 10. There they are. Okay, I don't have to step by 2, I can step by 4s. 0, 4, 8. Notice it doesn't put the 10 down, because 10 was not a step by 4. Okay, but back to the problem at hand. So we have row 1, we have row 2 defined, and we have M. Okay, and we've got to get the third row of M and the fourth row of M. Okay, now using the colon operator, I can say, MATLAB, I want the third row, all columns. Okay, so let's take a minute to savor this here. Let's savor that. Okay. I'm using this syntax. It says third row, and then I'm using the colon to say all of the columns. Third row, all of the columns. And I want that to be row 1 plus row 2. And look what it gives us. 3, 5, 7. That's exactly what I wanted. Okay. Now, I want that fourth row. So I'm going to say M, open parenthesis, 4, comma, colon, in the fourth row, all of the columns. That's what the colon operator in this situation is doing, saying all of the columns. And I want it to be row 3 plus row 2. Okay? But I don't want to type this. row 2 plus row 3. Do you know why? I don't have a variable row 3. See, it's not in the workspace. So if I type this and I hit enter, it would give me an error, undefined function or variable row 3. Row 3 is not in the workspace. Instead, I want to access row 3. So I can access it like this. 3, comma, colon. So this says M of third row, all the columns. So I'm going to take row 2 plus the third row. There it is. Okay. Now you might ask, what happens? Remember we had this guy Vec. Actually, let's go back. Let's make Vec all the odd numbers up to 11. You might ask, what happens if I try to maybe make a fifth row? Maybe make a fifth row where I try to put that vector 1, 3, 5, 7, 9, 11 into my matrix. Okay. Notice that this fifth row has 6 numbers, where all the other rows only had 3 numbers. Let's try it. So the correct syntax would be M5, the fifth row, all columns, equals Vec. Okay, let me try it. Enter. It gives me a syntax error. It says subscripted assignment dimension mismatch. And what that's telling us is, yeah, you can't do that because M has 3 columns. M has 3 columns, and you're trying to put in 6 columns there. You can't do that. All right. So tables, unsurprisingly, have to be rectangular. Okay, they have to be rectangular. They can't be this weird shape, where you've got this kind of L shape. You can't do that. Okay, so we get a syntax error there. Okay. I'd also like to show you just another neat little trick here. The single quote, which is next to enter on your keyboard, is the transposition operator. So if I take the transposition of M, what that does is it exchanges the rows with the columns. See that? So M, single quote. So now the first column is 1, 2, 3. And the second column is 2, 3, 4. The third column is 3, 5, 7. And the fourth column is 5, 8, 11. So remember when we did that example of we had the Vec equals all of the odd numbers, 1 to 11, and it gave us a row vector, okay, 1 by 6. I could also say, what's the transpose of that guy? And you see it's a column vector now. It's 6 by 1, 6 rows, 1 column. I also want to show you the length command. Okay, I can ask, what's the length of vector? Okay. Length is a built-in function into MATLAB. So it already knows what you're trying to do when you ask the length. So I've got length, open parenthesis, Vec. It says the answer is 6. It's 6 because there are 6 elements in Vec. Okay. If I give it size, we covered size recently, it says 1 by 6. Okay, 1, 6. 1 row, 6 columns. If I ask the length of vec transposed, okay, it gives me 6 again. Here's vec transposed. And if I ask the size of vec transposed, it gives me 6 by 1. 6 rows, 1 column. I can also ask it things like, what's the size of the entire first row of M? You see that? The entire first row of M. It says, yeah, that's a 1 by 3, 1 row, 3 columns. I can ask it, what's the length of the entire first row of M? Yeah, 3. Okay, clear that. All right, let me clear the workspace. Clear. All right. Let me give you a third way of inputting the original table. Okay, so the original table just had those 4 rows there. So another way is saying M equals square bracket. I'm going to use the colon operator now. I'm going to say 1 to 3. So remember what that does is that starts at 1 and it steps by the default 1 up to 3. So 1, 2, 3. Semicolon, because now I need a new row. Now I want to start at 2, step by 1 to 4. So 2, colon, 4. Now I need a new row, so semicolon. Now I have 3 step by 2s to 7. So I'm going to say 3, start at 3, colon, step by 2, colon, up to 7. Semicolon, because I need a new row. And now I have 5, 8, 11, so I'm starting at 5, and I'm incrementing by 3s to 11. So I'm going to say 5, colon, step by 3, colon, to 11. That's the end of my matrix. So I will put a square bracket there. And I will leave off the semicolon to have it echo back to us what M is so you can see it. There it is. Okay, so if you see these patterns, you can exploit the patterns using the colon operator. Now I want to show you some array matrix, we'll call it array operations. Let's say I have a matrix, call it A, equals, we'll say it's 1, 2, 5, 0. So let me write that down over here. So I've got A is 1, 2, 5, 0. There's my table in my matrix, A. And let's say I have B. B is negative 1, 40, 2, 0. So I'll write that down over here. Negative 1, 40, 2, 0. What I could do is perform some operations between these two arrays. suppose I wanted to add every element in this array or this table to its corresponding element in this table. As you might expect, I can say A plus B. Okay, and sure enough, I get 1 plus -1 is 0. 2 plus 40 is 42. 5 plus 2 is 7. 0 plus 0 is 0. Okay. Similarly, I can do A minus B. And there we go. Now if I want to multiply each element by its corresponding element in the other table, I have to use a dot. Dot asterisk. Depending on your level of mathematics that you've had so far, you may or may not know how to multiply matrices. We're not multiplying matrices. We're multiplying each element in this matrix by each element in this matrix. That's different. Okay? And we're not going to go into matrix multiplication. We're going to go into array multiplication, where we just simply want this, each element times its corresponding element in the other matrix. So if I need the dot times for that. So if I do A dot times B, you'll see that I've got 1 times -1, which is -1. I've got 2 times 40, which is 80. I've got 5 times 2, which is 10. And I've got 0 times 0, which is 0. I can also do division, each element division by dot divide. Okay, A dot divide B. Notice I've got 1 divided by -1, that's -1. 2 divided by 40, okay, that's 0.05. 5 divided by 2, that's 2.5. And 0 divided by 0, MATLAB says that's not a number. Interesting. Okay. Finally, I'd like to introduce you to scripts. Okay. So let me clear the command window. Let me clear the workspace. What I'm going to do is come up here and I'm going to say either new script, and if you don't have that, I'm going to go to new and choose script. And what that does is opens this editor window, and you see the flashing vertical bar there waiting for me to type something. What we can do is type in the editor. We're going to make a program, and we're going to run the program. We're going to type our commands just as we would in the command window, okay? Except nothing will be executed until we run the program. All right, so let's go back and let me try to get this original table 1, 2, 3, 2, 3, 4, 3, 5, 7, 5, 8, 11. Let me write a program that inputs that table. So if you remember, one of the methods that I did was I defined row 1 to be 1, 2, 3, like that. Remember, this makes a row vector with elements that start at 1, increment by 1, all the way up to 3. So it's 1, 2, 3. And I'm going to put a semicolon after that because I don't want the program to echo that vector back to me. Okay. I'm going to put row 2 equals 2, 4. So again, that starts at 2, increments by 1, up to 4. Put a semicolon because I don't want it echoed back to me. I'm going to say, all right, m of 1, colon. So that, remember, that means the entire first row of m. I want that to be row 1, semicolon, because I don't want that echoed back to me. The entire second column, or second row to be row 2. Now I want the third row to be the first row plus the second row. And I want the fourth row to be the second row plus the third row. And maybe, since that's the end of the matrix, maybe then I want it to echo back to me. So I'll type M, and I'll leave off the semicolon. Okay? This is a script. A script executes each command starting at the top and working its way down. And it executes them just as it would if you typed those individual commands in the command window. Except it does not execute until you tell it to. We're going to hit run in a second. When we hit run, then it's going to execute each line one at a time until it gets to line 7. Also, in your scripts and in your programs, just like you would turn in a handwritten assignment, you'll want to put your name at the top and the date. Okay. And look what I did here. I used the percent sign. The percent sign is MATLAB's comment operator. Okay. When you use the percent sign, it and everything after it turns green, okay, and MATLAB ignores it. It ignores the percent sign, and it ignores everything after the percent sign on that line. Okay, so this is purely for the human to look at. So you can leave other comments. Like, define row 1, okay, or define row 4, something like that. Echo M. Okay, so now I'm going to save it. So I'm going to come up here, save as. We'll say matrix example. And again, it wants to save in my default path, okay, my current path, which is MATLAB examples. So I'm going to save it there. And it shows up in the current folder. There it is. Okay, now I'm going to hit run. And there it is. Okay, it put in the table, and it echoed it back to me in the command window. So let me clear the command window. Let me clear the workspace. Okay, so the workspace is clear. Command window is clear. I'm going to run it again. There it is. It says that I ran the example. Okay, it only echoed line 10 back to me because that's the only line that I left the semicolon off. But notice everything is stored in the workspace as it would be if I typed these lines in the command window. Okay, row 1 is stored in the workspace, row 2 is stored in the workspace, M is stored in the workspace. If I wanted to look at row 1, I could, because it's in the workspace. Yep, there's row 1. Okay. If I wanted to look at row 2, I could. There it is, it's in the workspace. All right. If I close the editor window, okay, and again I clear the workspace, so I've got nothing there, I can double click my matrix example and it'll bring it back up to me. There it is. I can also just click on it and drag it if I want to run it to the command window. So we ran it, and there's the output. Okay. Good. So let's summarize the key points here. This was a lengthy video. Key points. First of all, a matrix and an array mean at this point the same thing. Okay? And you can think of it as a table. It can have any number of rows, any number of columns. A vector is a special type of matrix. It has either one row or one column, or both. And a scalar is a special type of vector. It's this both case. When we want to define a matrix, okay, we need square brackets. Square brackets. And we will input our first number, and then we will change the column using a comma and a space. Then input the next number, and then change the column, put a comma, input the third number, etc. When we want a new row, we need the semicolon. That tells MATLAB that it's a new row, and then I enter the element, then I need a comma, etc. And then I need a square bracket to tell MATLAB that I'm done with the matrix. I have two choices of how I want to access an element in the matrix. I can use subscript notation, where I put the row, comma, the column. For example, M of 2, 2 would access the element that is stored in row 2, column 2. That's called subscript notation. I can also use linear index notation, where I give it just one number in parentheses. That will access the sixth element of the matrix. Okay, this is linear index. And you might ask, well, what is the sixth element? Well, it counts them column-wise, so it goes down the columns. It stacks the columns on top of each other. Okay. Also, to multiply elements of two matrices, I'm going to use dot times. Okay, so that's the period followed by an asterisk. And to divide, I'm going to use dot slash. Okay, remember the single quote? Is the transposition operator. It switches the rows with the columns. And remember that all-important colon operator. colon operator. So I can make vectors that have patterns in them using the colon operator, where I'm going to put the number that we want to start at, colon, the number that I want to step by, let's say 2, and the number that I want to finish at, let's say 11. That would give me 1, 3, 5, 7, 9, 11. Or I don't have to start at 1, I can start at, say, 3, and I can increase by 3s, and I can go, we can do the Schoolhouse Rock song, 3, 6, 9, 12, 15, 18, right? So we can go to 18. So this would give us 3, 6, 9, 12, 15, 18. Also, I can use the colon operator to access the entire row of a matrix. For example, 1, comma, colon would access the entire row of matrix M. M2, comma, colon would access the entire second row of matrix M. We didn't do it, but we can also use it to access entire columns. Colon, comma, 1 would access the entire first column of matrix M. M, colon, comma, 2 would access the entire second column of matrix M. Okay, in this lengthy video, we also looked at the keyword end. Okay. So this is a reserved MATLAB word. We don't want to use it as a variable name. Okay. It's already defined, and MATLAB knows what we want. So M of end would give you the last element in the matrix, for example. We also looked at the built-in functions size and length to get the dimensions of a matrix or the length of a vector. And finally, we learned what a script is. Okay. A script is a collection of commands that are not executed until you run it. Okay, so we made our first program today in our script.